Okay, I would like to ask you to go back to your seat, please. Would like to get started.
I can find my place for my legs here.
So the sessions for today were all about how do we make data science work, and the first session was about, well, let's see what we learned from successful collaborations. So we heard a little bit of that. And then the second session was about opportunities for collaboration given pent-up demand for solving some problems. And we had a panel what was mostly new faculty to BU, and it was really exciting. And then we had the lightning talks where we heard from faculty about sort of opportunities for engagements. And then we decided for the session, the first one after lunch, is enablers of data science. So think about the catalysts. One of the questions in the data science, for the data science task force was really about support of research or education. Remember that data science is both. So what we decided to do is reach out to lots of the offices in the university that provide very important services and support for data science across the board. It may not apply to particular research, but it does touch data science. And rather than try to organize this in any sort of thematic way, because all these things we just decided to go alphabetically. So with that, I'm just going to stop and let everybody speak about who they are, what they do. We'll have some time for question and answer at the end. It is very important to know that these resources exist. As Jean mentioned, some of these resources are unique to BU. They just don't exist anywhere else. And that's an advantage. And that's an advantage we want to build on. So with that, we'll start with Eleni.
Thank you, Azer. So I'm here on behalf of BU Libraries to talk to you about how we help data scientists. Generally speaking, we apply the principles of library and archival sciences to help meet the challenges and needs of researchers and students throughout the research life cycle. As you can see from this very familiar diagram, this includes assistance from the very beginning of a project or starting to develop a class, a curriculum. So we help with finding data sets, preparing data management plans if you have certain funder requirements, managing the data and research and other research outputs, as well as curating and finding the appropriate place for you to archive all of these materials and to preserve them beyond the life of the project itself for reuse and even for yourself to reuse it in the future. But more specifically, at BU Libraries at the moment, we have research data guides, which offer best practices for data management plans, for how to share your data, where to archive your data. We also have training and consultations on request. So in the past, we've worked with individual researchers. They've contacted us to help with writing up a specific data management plan for a project of theirs for the NSF or the NEH if you're in the humanities. And we've also done workshops for how do I use places like the Open Science Framework to manage my research project and the associated data sets. We also have our own institutional repository, which it's not a data repository per se, but if you have smaller data sets, we offer a place for you to archive and get a persistent URL identifier for these data sets if you need to provide that for your journal, article, or for a funder. We also, on a related note, on OpenBU, which is the institutional repository, we have theses and dissertations from the beginning of BU till present day, which we can imagine that some data scientists might be interested in seeing what kinds of research were graduate students interested in throughout BU's existence. In the future, as far as the services for data scientists that we're hoping to offer, we are going to be looking for a new associate university librarian for digital strategies and initiatives and innovations, pardon me. And one of their main goals, one of the main tasks is going to be to work with all these different leaders within BU's research, ISNT, and other units to make sure that that we can work together to provide the services we need in a more coordinated way. As well, we've been looking at some of what our peer institutions and other similar institutions that have data services within the libraries offer, and some of them include data curation services for researchers, and also embedding library staff within a research project from the very beginning to help with any of the needs that you need to manage these data sets throughout the project, and then archiving it for the longer term. So I'd like to also ask you all if you have any questions or feedback about what we can do at the libraries to make our services more visible, and what particular services you'd like us to offer. This is the perfect time, so please come talk to me afterwards. Thank you.
Thank you. All right, Ziba.
Okay. Hi, everybody. So this has already been useful for me. I'm going to be calling you later. I'm Ziba Cranmer. I'm the director of BU Spark. We are one of the initiatives incubated under the Hariri Institute. I'm going to tell you, can you do the next slide? I'll do it. I'm going to tell you a little bit about our programs, or some that I think that will be relevant to you. So we are sort of similar to the Hariri Institute in that we're a crossroads for computing, computational sciences, computer science engineering, and the rest of the university. And we were also started to support students to pursue their own innovation ideas. And one thing we realized early on is that in order to have their own innovation ideas, you need to get exposed to more possibilities. So we started the X Lab, which is the experience lab. And for the X Lab, we recruit projects. I call them acupuncture projects. So they're projects you can complete as part of a class project in one semester that have very clear deliverables, data sets usually ready to go, or clearly identified where the sources are. And students can work on those projects, over the course of about 60 hours times 3 students, and complete them on your behalf. We also have a program called the Practicum, which can take on meteor projects that can cut across different disciplines. So it could be not just a data science project, but it could be a data science plus a pretty simple software engineering project. So that's the X Lab, and we have an application on our website, and you can submit applications or give us a call, and we can meet with you and see if we can meet your needs. And it's sort of like a mini consulting project of different sizes and across different technical disciplines within data science, machine learning, et cetera. We also have programs where we have students working on a general innovation idea that maybe where the solution isn't clear, and they can join with other students from another college, and we're piloting the cross-college challenge through a cross-college fellowship where we join students from different disciplines to work on a project over the course of a semester under our supervision. And then the third area are hackathons and events, and the computer science clubs. We have connections with about 18 different computer science and engineering clubs, and they are constantly doing a variety of activities, and one of which are hackathons. We have 2 major hackathons at BU every year with 500 to 1,000 students, and it's a great place to get some initial exploration work done. You likely will not get anything that you can use, in its entirety, but it's a great place for exploration. I'll give you an example. We did a project for the city of Boston on identifying the quality of cracks in streets using Google Street View, and they had this general idea to see if it was feasible. There were about 6 different submissions that took all different directions, and it gave the city an idea of where they would then take that project for the next iteration. Then they submitted a project that we are going to do over the course of next semester. Okay, I'm not going to give my examples because I think I probably took my 5 minutes. So thank you.
Wayne's going to give you.
Yeah.
There you go.
Hi, my name's Wayne Gilmore. I'm the Director of Research Computing for Information Services and Technology. And our group provides core infrastructure, so compute and storage resources for the research community. Currently, we have about 2,300 active researchers using our cluster. Our main resources the shared computing cluster, which is supported by the university, but researchers also partner with us and purchase compute and storage to help augment the cluster as well. So it's a great partnership with the research community that's working well. In addition to the core hardware resources we provide, we also provide consulting and programming services for the research community. This is free of charge, so essentially you can ask us for help and we will look over your programs and help you come up with workflows for what you're trying to do for your research to use on the cluster or even on your desktops and workstations. We also do visualization as well. And the third main component of what we do is training services. So we try to provide general and customized hands-on training. This is free to the entire university community. So we're running through our spring training program right now. And on the website, you can see our schedule as well. Some of the topics are data analytics, statistics, and computer programming. So in the past year, we've given about 173 training sessions over 35 topics. And I put this slide up just to show mainly the targeted areas in which we support data science. So there's all these common workflows and application stacks that I think many of us throughout the university use in their research. And the graphic on the right just shows the different communities that we support through the university. So things like R, Python, and MATLAB, these are used by many different groups around the university, and I think to the interdisciplinary research mission of the university, as more groups start working together, these common frameworks are very important. In addition to these frameworks, we have consulting programming services that will focus on machine and deep learning. If you have things that need large-scale memory or large-scale compute, we help tailor those workflows as well. And then best practices for large data sets, which is pretty important as well. And then for the training and tutorials, we do our basic intro training tutorials. We'll do advanced data analytic tutorials and visualization. We do collaborative tutorials in Git. But we'll also come into your lab and group and do customized targeted trainings as well. So if you have a lab, like 4 or 5 members, and you want help on your specific workload, we'll come in and do a 2-hour session with just your lab and help train them as well. So if you want more information about what we do, please visit our website. It's on the bottom there, rcs.bu.edu, or feel free to email us. And I think there's brochures across from the reception desk that you can pick up as well. Thanks.
Thanks, Wayne.
So I'm Ron Krieger, PI for the Mass Open Cloud. This is great because this is actually one of our industry partners charts. Looks a little compressed here for some reason, but talking about why the public cloud is a terrible idea right now. So, data lives in a cloud. Compute is what you do with science on data, and it's all kind of moving to the cloud at some level. Could we create an alternative to that? So the Mass Open Cloud, so the SCAN was a presentation by a partner, was a model saying that many stakeholders, rather than just one vertical integrated provider, provide the whole thing. We want to create a multi-sided marketplace where there's incentive for multiple companies and providers to stand up a shared cloud, and where users can pick between them. So this next chart sort of, which doesn't work, there we go, talks about all the different partners that participate in this. So this is a BU-led initiative, set up a cloud for you guys. Right now it's 1 petabyte of storage, about 2,500 cores of more or less commodity Intel platforms. All these partners have given us parts to be part of this. We have a large Ceph, which is object storage and block storage. On top of that, you can carve out individual machines and allocate them at the bare metal. We have an OpenStack layer where you can get VMs, just like you could on AWS on top of that. And we now have a containerized platform. So these are all the different kind of base services you can get. You can spin up a Spark or Hadoop cluster in a few seconds. You can have your own environment with continuous integration, monitoring, load balancing, and sort of all those tools exist on the cloud that you guys have access to. Recently, Red Hat just stood up They want to build a new data science platform, and they want that to be something that they could sell to all kinds of different enterprises. So they're doing it here. They're doing it on top of the Mass Open Cloud, and they want to offer it to researchers to have a platform where they can actually get real users on it at early stages as they're building up. This is all built on top of open source, so any parts of this could be modified, and they actually are looking for collaborators that actually want to develop the technology together with them. Recently, till now, we've had a really boring commodity Intel platform. IBM just provided us with 400 Power 9 cores, 40 GPUs, so these are NVIDIA Tesla V100 GPUs, so they're really, really fast NVLink. So it actually, it has fast access to all of the memory, and you're talking about terabyte of memory of these machines, but also they can actually communicate with other machines, so you can have distributed applications across all of these different machines. And they've won all kinds of awards for big data platform. So we'll be staying a lot of the same infrastructure on top of that that's being racked and stacked as we're sort of talking right now. So in the next few weeks, we should be making that available to you guys. Harvard has just made a commitment to move Harvard Dataverse off of AWS, where it lives today. So this is the largest data set repository in the world. It's pretty cool. You can actually publish your data set, get a URI to it, and make it available in perpetuity to other people. And and you can actually choose whether or not you're sharing your data set or not. And the cool part about this is that it's been really expensive for them to host this on top of AWS because of download fees. They'll be moving it onto the MOC, and people will have access to it in situ, computing on it inside the MOC. So this is available now. It's starting to get increasingly interesting platform for data science. And it's kind of stone soup. It's something where all the different partners in industry and providing components, a whole bunch of researchers are working on the plumbing layers of this, and we'd love for people to use it more.
Hi, I'm Andre Lapitz. I'm director of the Software and Application Innovation Lab at the Hariri Institute in Boston University. So the Software and Application Innovation Lab was started about, at this point, almost 4 years ago. And the purpose of the lab was to help researchers across the university who have a data science, computational science, or software engineering component to their research, and would like everything from consultation about how to put together the proposal in a competitive way, so some boilerplate text or something like that, all the way up to having a co-PI who's a computer scientist, or multiple co-PIs who are computer scientists, and who have team members available who are professional software engineers. And the idea is that this would make BU researchers more competitive when they're applying for these kinds of opportunities, because what you can say is, I'm putting a software engineer on my, in my budget, and they're going to be available to start working immediately when the project is funded. And of course, they're experienced and have worked on similar projects. We focus a little bit on things like full stack development and custom application development, particularly production quality work that partners could actually use and deploy. We've had a lot of success with the city of Boston and other external partners actually deploying real applications that are used by hundreds of users. And that's a lot of the sort of unique experience that our team does provide. So our team is about 10 full-time people right now. And usually about 5 to 15 interns at any given semester. The other thing that this kind of provides as an advantage is the skills are retained within the community. So after a project is completed, it's not some external contractor who basically leaves and maybe even takes the source code if you didn't negotiate that properly. The team retains the skills within the university. We advocate for open source development wherever possible. We'll help you make your project sort of modular in a way such that the open source components, if they should exist or can exist, will be separate from the proprietary work that you do, so you're not rebuilding the same backends over and over again and using funding for sort of that kind of duplicative work. And we do provide, again, for the BU student community mentorship and an opportunity to have an internship that's almost industry-like in terms of the professional mentorship we provide and sort of learning industry best practices, but it's still on campus. So our interns after this opportunity have got on to work at Amazon, Facebook, Google, and all those typical places. And I'll just briefly describe what the benefits of this kind of entity have been. In many cases, there's this ecosystem that forms where, because of the relationships that we build with faculty and researchers across the university, we're actually able to identify new opportunities. So we might build a relationship with the city of Boston that then allows them to have the trust in us to let us know about a new problem. We can then take that problem, go back, build an application or a solution for it using some kind of research topic, like what happened in one of our cases with cryptography. And as a result of that deployment, we're then able to go back to the NSF and say, hey, give us a cyber infrastructure grant based on this work so we can help additional partners, nonprofits, other governments, deploy this technology. And we've had a lot of success with that. We've had many multi-million-dollar grants as a result of the collaborations that happened because of the ecosystem of the Institute and because of the relationships that we were able to build by solving problems with partners, both internally within the university and outside the university. And this picture is just kind of an illustration of the various areas in which this has occurred. And the cycles you see in this picture are those kinds of stories where a relationship actually ended up forming some kind of product that led to papers, that led to a grant, that led to additional funding in a different area. So, thank you.
All right, so good afternoon, everybody. My name is Matt Ogrodnik, and I'm the director of the Institutional Review Board at Boston University Medical Campus. So the Institutional Review Board on the medical campus is, our role is really to review human subjects research that occurs at the institution with the goal of ensuring that research is conducted in both an ethical manner and also in accordance with the federal regulations, with institutional policies. So at the Med Campus, we have 4 separate committees that review research that is generally greater than minimal risk. And so these committees are built of scientists and non-scientists. We also have community members who review research according to a set of specific regulatory criteria. So as I said, we review studies that include some risk to participants, to human participants, along with studies that have perhaps an overarching ethical issue. But actually, the bulk of the research that the Institutional Review Board reviews is actually not greater than minimal risk research, and that's performed by generally IRB staff with the help of consultants that have some expertise in that area. And so the medical campus IRB, just to be clear, reviews research for the School of Public Health, for the dental school, and for the School of Medicine, along with Boston Medical Center. The Charles River campus has their own IRB, and so they perform essentially the same function as the medical campus IRB, just for the Charles River campus. They have different staff and different committees, but they're really reviewing, they're performing the same role. And so just to delineate the types of research that needs to actually be reviewed to the IRB, because we get a lot of questions about, does my research really require IRB oversight? So we're really charged with reviewing human subjects research. That's really the purview of the IRB. So that's research that involves collecting data through interaction or some sort of intervention with living individuals, or research that involves the analysis of identifiable data. So if you're obtaining private identifiable data on living individuals and analyzing that. So we will also review, and a lot of maybe big data science projects are more in this vein, we'll also review research that does not involve identifiable data. So we review a lot of studies that maybe are on de-identified biospecimens or on large secondary data analyses studies of de-identified data sets. So we will review those. Oftentimes the database that's releasing the data requires IRB oversight, some sort of formal determination letter, or perhaps a journal, or the funder would like an IRB determination letter. So we do review those types of studies. They're just not necessarily, they don't need to be submitted to the IRB. If you're confident that what you're doing is not human subjects research, you don't need to submit for IRB approval or review. But we're always available. You can always reach out to us if you have questions about study design, if you have questions about whether your project requires IRB review. So the IRB, along with the Clinical Research Resources Office at BU, are happy to help you design your study as well. Thank you.
So while the transition's happening, I just looked over and saw Saul, and I realized I promised to mention that underneath the MOC, there's the Northeastern Storage Exchange, which is 12 petabytes of storage that's just becoming available soon.
Yeah, it's a new joint project. BU is the lead institution. It's BU, Harvard, MIT, Northeastern University, and the University of Massachusetts, mostly at MK and PCC.
All right. My name is Michael Pratt. I'm representing the Technology Development Office at Boston University. We're not the IT department. That's the name is confused sometimes. Our primary services are all around intellectual property. Mostly patents, somewhat around copyrights. We manage new ideas that faculty have in their research, licensing those or transferring those to other parties and collecting royalties if there should be some. We're also involved in several support agreements if you're transferring materials out or if you need to do confidentiality agreements around the licensing of technology. And we run a funding program called the Ignition Award Program, which is intended to kind of bootstrap or help launch you towards getting impact of your technologies to see real-world applications of those. And we have another function, which I'll talk about more on the second slide, around faculty entrepreneurship that I'll speak to in a moment. We also get involved in a lot of supporting services. So whenever there's a research agreement with industry that involves some IP terms, they refer to our office for a consultation on those to make sure that we're meeting your needs and making sure your research, the integrity of your research is protected and not overly encumbered by some IP terms that industry may want to put on you. We'll consult with faculty and students at any time if they have any interest in starting companies or forming a new entity, whether it's just a basic consultancy or a full-blown VC-backed startup. At any time, if you're groups, lab groups, or classes, you want to have a guest lecturer, someone from our group, we're happy to talk about intellectual property or company formation. If you have any questions about the intellectual property policy, feel free to call us. We do live and breathe that every day. In general support on all IP-related matters, so weird things come up all the time, and our office will get pulled in to different things at different times. I think with data sciences, it's a new challenge. I mean, over these past 20 years, we've seen that the evolution of business models in open source, it's more about execution and data access than it is about proprietary rights. And you have open systems and closed systems. And so if you just want to sit down and talk with someone about that and a strategy about how you get the most impact from your work, it doesn't have to be just a patent focus. It could be, how do I talk about an intellectual property strategy that can help me realize the impact? It could be a brand strategy, or in these information products, a lot of times it's about access and getting a certain critical mass of customers for your products. We'd be happy to talk to you about those. And to super simplify, I did a slide that goes beyond just our group. So on the left-hand side are two employees that work in technology development. Rana Gupta joined us in September. He focuses on faculty entrepreneurship. So if you have any questions about being involved with a new company, any dimension of that, Rana will be happy to sit down with you, talk you through it, and help you through different programs. He also runs the Ignition Award programs. Rana has been the CEO of several startup companies. He's been a venture capitalist in the past. He's got a pretty good perspective for you. If you have new ideas that you think could be protectable, or you just want to talk to someone about your idea, you should contact Misty Farrell in our office. She'll sit down with you, understand if your idea is protectable in some way, or copyrights or whatnot, and decide how to go forward, or if it relates to license agreements. And then outside of technology development, since they weren't on the panel, I figured I'd give them a shout out. We have a new group at Boston University called Industry Engagement, and that's led by Mark Scotamacchia. So if you want to collaborate with industry in any way, shape, or form, whether it's student education programs or broader support on research engagements, Mark is staffing up a team of people to help faculty and research groups interact with industry. And Bill Segara has been here for about 5 years now, handling all the industry contracts. So I think for this group, if you have a data use agreement, data coming into the university, or you're sending data out, Bill's going to be the attorney that negotiates that contract for you. So it's important to kind of help him understand what your needs are to perform your research so that we can negotiate the proper terms in the contract. And of course, I work with Bill all the time because every research contract from industry has some intellectual property term in it, like it or not. And so we kind of all work together as a group. But I think those are the key people to talk to. And of course, you can talk to me at any time. Thank you.
Okay, thank you. Thank you very much. It's always a good sign when your panel barely fits on the stage. Hi, everybody. I'm Emily Robbins. I'm with the Initiative on Cities here on campus. And for those who are not familiar with us and what we do, we are a research center where we're focusing on supporting faculty that are doing research on urban issues and on cities. You may have also seen we publish annually the Menino Survey of Mayors, which is a study that we do every year, a national study asking mayors about their priorities across the country. And so when we talk about cities, we really mean city with a capital C, the local government. And I know government is not always the most likely research partner, but I am really here to tell you that cities and local governments can actually be really great research partners, especially around data science. And so if you think about it, cities have a ton of data about their residents, about their housing stock, about their school systems, a number of different things that they can actually make publicly available to you to help you understand and answer your research questions. And then also at the same time, we have really found that cities are actually an interesting unit of study. And so cities that we work with are very upfront and recognize that they don't always have the time or the capacity to take on some really extensive data science projects. And so they really look to the research community to help them answer some of those key questions. And actually a really good example of that is if you take a look at the city of Boston has a civic research agenda online. And it's a list of over 200 questions that the city has actually put forth and asked for academics to help to study. So I wanted to just show you pretty briefly 3 different ways that the Initiative on Cities can be helpful with your research and also to students. The first is we have early stage urban research awards. This is where we invite you to submit a proposal on an urban topic that is of interest to you. And we have a pot of money where you can receive up to $10,000. We give this to both students and grad students and faculty. The deadline for this is actually coming up pretty soon. It's March 17th. And if you have any questions about that, I'd be happy to help answer them. We also have more information on our website about how to apply and also what has been funded in the past. Another way that we want to be helpful is we would love to help you build an audience for your research. So we have public talks and seminars just about every other week during the academic year. We would love to have you come in and feature you for a talk. And this is a way that you can help build a new audience for your research. And then lastly, the third way is through the MetroBridge program. This is a new program that we have at the Initiative on Cities where we're working with faculty to actually partner with cities to do real projects for a city as part of courses that you teach here at BU. For example, we're actually working with the Spark team and computer science students this semester to work with the city of Chelsea to actually create a gentrification mapping tool. So this is just another way that you can start to work on this in the context of what you're teaching and also start to build a research relationship with a city. So I will end here, but I'm happy to stick around and answer any questions afterward. Thank you.
Hi, my name is Masanobu Ojima. And wow, there's a lot of information. I'm taking so much pictures about these slides. And I'm just going to add one more to this. So if you have data and if you have questions, this is a service that you may want to be interested in. So Mssp Consulting is a consulting center that serves the BU research community, and I'm representing that as a part of faculty in the Department of Math and Statistics. So oh my God, the fonts are so small. So Mssp is stands for MS in Statistical Practice. It's a one-year master's program designed to train students who are trying to go into the broad data science field as their professional career. And in the statistical practice program, we provide this thing called statistical consulting as an educational tool in a 2-semester statistical practicum. From our perspective, the consulting projects are an educational tool that provides hands-on experience to our students, and it's also a tool that students can use to actually bridge the gap of the employer's work experience that they expect from when you apply to the jobs. So as you can see in the below picture, clients who are BU researchers. You will bring us research. We provide our expertise. And in the end, you would get your analysis. The students will get their experience. So it's a win-win situation. How it works is that our MS students team up with our PhD mentors, and they do most of the execution of the consulting. There are 3 levels of service that we provide. The first is on one of our PhD student terms as one and done, so it's about at most 1 hour of just talking. Limited duration is the second level. It's about 10 to 20 hours of student work. And third level is an extended duration. Extended duration is more like an academic collaboration. The length of the projects depends on the projects. And up to limited duration, all the service we provide are free. And beyond that, we usually ask for an authorship or maybe student support. So the typical student experience would be that you make or typical client experience would be that you make online requests. We reach out and we'll have an intake meeting. Then we send you an agreement form. It's a non-legally binding form which summarizes our understanding of what your project is and what we will promise you. And then the collaboration happens. So you'll do an interaction with our students. And then in the end, you get a written report. All the process will be supervised by the faculty statisticians. And so even though you will be interacting mostly with the students, all the works will be monitored by us faculty. So just to give you a highlight on what we have been doing so far, up to this year, we served about 70 or so projects every year. This year, we're projected to go up to 80. And we serve a variety of faculties and researchers, as well as PhD students and graduate students across campus. So just to give you an idea, we work with more physical science research like Adrian Fitzy in the biology department on biogeochemistry data or research, or with John Levy on assessment of particle matters around Logan Airport, to more social science like in the Wheelock College with Professor Melissa Holtz on trying to understand violence exposure of LGBT population. And we work with more intervention type of study with Professor Jessica Kramer from occupational therapy on a project team where it's a study to train students with disability to resolve environmental barriers, and aware studies where where she tries to improve the mental and sexual health of Asian American women. And we also have a unique relationship with the genetic counseling program where we injected ourselves in their 2-year program, and the students, so in the 2-year capstone project in their students, so if we go to their proposal at the early stage, we give suggestions. When they get the data, we do help them in the analysis. And so this is another way in which you may be able to engage this in your program. So if you're interested, if you have data, please look us up. All you have to do is make online requests, and then you will get email within 24 or 48 hours from our students. Thank you.
Thank you all. Let me make a few comments about the Institute's role. And I always like to use the word, the Institute is a crossroads. Maybe another word that I'm trying to use more frequently now is a public square. If you think about this meeting and the breadth and the different type of interest, it's really unique. You don't get that in other meetings about any discipline. And if you look at the set of people sitting on this table and the kind of things that I thought would be good to make you aware of, it's so diverse as well. So it's not just the technology part. It's not just the analytics part. You know, we have the library here, and we have IRB here. You may not know that you're working with data you're collecting from Twitter, but Twitter are people. Maybe I need to worry about that. So in doing this, I just want to say that the diversity of services is really a reflection also of how data science is that connecting tissue across all disciplines. So with that, I want to mention a couple of comments. For example, there is a lot of data. I mean, you heard about the city of Boston has data, or maybe city government has data. Guess what? Boston University has data. It has huge amounts of data. And one of the things we're working on is why not expose that data and make some of this data available for research? Let me give you a few interesting things. Through ISNT and facilities, there's all sorts of systems that connected my mobile right now to a Wi-Fi base station here. So there is a way to find out who is where when. Everyone in the BU community, right? This is huge data sets, could be used for many studies. Now, you don't have to be careful. There's all sorts of platforms you have to do on that, et cetera. But to me, I think that's a wonderful example of how even within BU we can connect the dots. Very happy to work with ISNT on a couple of projects that maybe there'll be pilots in order to do that. The other thing I'd like to say is, just going back to something that Ziba mentioned about Spark. Today, I was just listening to all the talks. There is so many projects that cry for, hey, why don't you just put this through Spark and get some students interested in it? Some of the problems are hard. Maybe students cannot do it. But some of them are doable. They could, exactly. So I think that this gets me to talk about what I like about data science. It's really about the ecosystem. If every one of these things works on its own, it's not going to be as efficient. It's really the connection. And I like to see it as a spectrum. So I'll take just an example. The library, when they do an archiving job with data, that's going to be like forever. This is like the golden standard. But maybe I don't need that. Maybe I just want to keep it for a few years and I need something very resilient. I go to ISNT and that's fine. I store it there. And maybe even I'm more adventurous and maybe I want it for free or almost for free. Then I'm going to go to Oran and say, hey, I'll put it on the MOC. It's less reliable. Think about. They mean it that way. So think about the spectrum. We need that spectrum. The same thing happens with projects that you can do in a course versus projects that you can do with the wonderful software engineers in SAIL, et cetera. And so I just want to finish with this notion. There is so many choices. There is a spectrum, and these things connect to one another. They're not really separate. I don't like to see SAIL and ISNT and MOC being different. They're just handing from one to the other. I can imagine a project that starts by going to the consulting, the Mssp. And they say, well, but you need to get data, or maybe, well, then go to SAIL. Maybe talk to them about how to do that. And then the data comes. Well, where I'm going to store the data? Well, that's the question that ISNT have to help with. And perhaps I want to visualize the data, and then I'm going to use research computing for that. So I think there is an ecosystem here of services and enablers that I think is good to see together and also to connect the dots. I'm hoping that today will result in some of you talking to one another. Who knows? So with that, I want to open up for questions from the audience. Any questions? Vijay, you have a question?
So I have a question for Wayne on the research computing services. Yep. So we are in the Med campus and we use extensively the whole resource that you provide us. But I think at the same time, I want to understand how these things are going to scale up, because our needs are only increasing. And we use more than what we used to use a year ago. And now I already start getting emails from my students from my lab saying that, my job got submitted and I only got it running after 24 hours or something. So how are you thinking about scaling these things in general?
So I think we've been pretty good at offering a fairly scalable on-premise solution, right, to the research community. And I think a large part of that is being able to have researchers be able to buy in, right, for priority access to resources. So this is through our buy-in program. But I think there is a real challenge moving forward as more and more areas of research are becoming dependent on computation and data especially, which is the really big topic that I think everyone in this table struggles with. And it's not just a BU problem, it's very much a national problem and a worldwide problem. And I think for our group, looking to augment our services to be able to work either in things like public or private cloud, right, to help piggyback those services. To work with the funding agencies, which I think Azer does a lot, to come up with good models so that researchers can actually pay effectively for services moving forward. That's a big question as far as the economic scale, right, especially of cloud right now, and how we solve that for the research community. So it's a big challenge. We do the best we can to offer a fairly economical service to the research community with subsidization from the university. So that's important, that the university is actually providing core funds to help you do your research as well. And hopefully we can continue to go down that road and explore these other areas.
This actually, thank you for mentioning how funding agencies are struggling with this. This is a national problem, absolutely, because if you just think about it, just the amount of data being generated, and if everybody wants to keep all the data, I mean, multiple copies of it, it's just not sustainable. So the approach, one of the issues is if it's free, you're going to abuse it. I think ISNT had some reports about how much data they have that nobody's accessing, but it's still sitting on disks and rotating there, consuming power and all that. So I mean, I work with NSF. There's all sorts of very interesting ideas for how to support infrastructure. I'm going to give you just one. Well, first of all, it cannot be free. So you as a researcher have to think about the economy that sort of, you have to be spending real money. It's your grant, but it's not free. But how do we do that? Okay, so one of the ideas, for example, is we borrow from the open source community. In software engineering, when something is valuable, you put it out in open source. And you know what? If there's a community that gets around it and supports it, that's a market demand. Then it's worth keeping. And we have this great collaboration with Red Hat. That's what they do. If there's something that is worth supporting and even making it something that they can sell or can help service, they'll take it over. And I think one of the things we are thinking about is data should be the same, in the sense that if data is useful, then there'll be demand for it. And if there's demand for it, there'll be a market, then it will generate the funding that's necessary for it. So I think that BU is struggling with this, and we should think also institutionally about when a new faculty gets hired. I think I mentioned this almost intentionally with when the provost was here. When you think about the infrastructure need for life sciences, they need to get wet labs, and it's understood that a faculty, there's almost a lifetime cost associated with getting one faculty in the life sciences, and it has nothing to do with supporting graduate students and postdocs. It's really the infrastructure. So if you think now with data science, every time you hire a data scientist, you should think about what is now the level of support you need for that. We often joke in computer science that the infrastructure need of a computer scientist is a notebook computer. It's a very cheap infrastructure, and maybe a fancy building. But actually, it's a cheap building when you compare it to the wet labs in terms of what you have to do in a building like that. So in any case, this idea of putting a price on it and factoring that into your cost is very important. Unless we do that, then we'll always go into this, have to ask for NSF for money or have to get gifts or whatnot, which is not sustainable. Especially with the increase, I mean, if the size of data was constant, I can see it, but it's doubling every, I don't know how many months now.
Just another comment. We talk about the economic factors a lot, but I think there's the technical factors as well. And you look at the data science community, and especially the work that the AI lab and groups like that are doing, the machine learning and deep learning, and the fact that there are very few commercial platforms and commercial technologies like GPUs available. They're owned by very few companies, one, NVIDIA. And that makes research very expensive for the community. And trying to solve that is a technical problem as well as more innovation happens in the accelerator space to support those type of workloads moving forward that I think most people in this room are starting to think that they need to depend on more. Right, to tie these different data sets together from different domains. So I think that's an important consideration as well.
I have a follow-up question. So we talked about the technical side of things, but what about the human side of things? How do you scale up, in light of the data science initiative, with more and more people that are going to be exposed to data science? Yeah. I imagine that there will also be more people. Oh, thank you.
that there would be more people requesting resources of IRBs, of RCS, of MSSP. I mean, you can increase your F&A rate for, for so long, I guess, until you run into the issue there. So what's the plan to scale up that piece? Not directed to any specific person.
Yeah, that's a question a little bit above my pay scale. But let me just say that first of all, this is not unique to BU, right? So this is a universal question. And as we shift to using data, we may think of it as free, but actually there are lots of costs. And you mentioned some of this tech, just storing it, managing it, the technical component of it, securing it. I mean, it's hard, right? So I think we actually don't know. The answer is we don't know sort of the factors with which we have to grow different parts of the university based on these data sciences. I think it's fair to say that this is a transition. It's going to take 10 years, 20 years, but it will change. Like if you think about, I don't know, like a new technology comes in, it changes how we consume things. And maybe the F&A rates will not go up, but actually a lot of it is going to go supporting this as opposed to electricity or whatever else, right? So the point is that, maybe the wet labs are going to be a thing of the past or less of it and a lot more of this. So I think that because of the transition we are going through, we're not steady state yet. We don't know. I may be going for a proposal to NSF with MGHPCC to think about, well, maybe all the academic community has to act as a block in order to secure cloud resources at a cheaper price. Because think about we're a block, we can negotiate now. We're gonna get a lot of cycles. Well, the NSF is actually trying like 5 different ideas. It's not one. We don't know which one is gonna work. And it may be that multiple versions will work. But I think, to your point, I think a lot of it also is a learning curve for the university to appreciate these things. All of you are pushing the envelope. You are actually pushing your department, your college, and the university a little bit as a discomfort. You are probably the first, some of you are the first faculty to be hired dealing with data. So they didn't have that question to answer before. Now they have to go ask that question. Now they have to factor these costs into it. So I think that's, we are a little bit of a sandbox and an experiment for the university. Well, not an experiment, but we're pushing them, and there's a bit of balance that will happen over time. I know I didn't answer your question exactly. I wish I have a plan. But
maybe just to add one more thing. So, I think in research computing circles, the big thing that we're concerned about as a group, me and my peers, is the workforce of the future. And we have huge concerns about that right now. Essentially, it's very hard for me to hire someone with domain experience that knows data science or it has enough technical ability to help lead the research community into doing their research. And we need to build that workforce of the future. If we don't do that, then we're going to be in big trouble. The other side of it is you build that workforce and they come to work for academia and they very quickly get hired away by industry because industry is having the same struggle that the academic community is, but they can pay a lot more. So.
Actually, we had an advisory board meeting and we had somebody from IBM and I was talking about all the pain points for the institute. Much of it is along these lines, some of it. And they have exactly the same problems. And I think that we are a university after all. So if we don't figure out a way to produce that workforce, then actually, I would say society is doomed, or maybe our economy is doomed. So actually we have a job to do. We have to be creative about how to do this. And perhaps think of this as an opportunity as opposed to a challenge. So there were questions, yeah.
So part of the promise of data science is not just analyzing large data sets, but also sharing them so that thousands of minds can be brought to bear. And I'm wondering about your thoughts on the ability to share large data sets. For example, Warren mentioned that Harvard Dataverse is currently the largest data repository, but it's not a repository for large files. If you have more than 2.5 gigabytes, you can't upload. And so I've got about 35 gig to share. I've been in touch with ICPSR, and they've made an exception to give me 40 gig of space, but that's not their typical model. I'm wondering if MOC will address that, or the library perhaps. Like, what should we be thinking in the future?
Yeah, so a couple of comments there. That's actually why Dataverse is moving from AWS to the MOC, is because they can't support large data sets there. And it's actually going to be sitting on top of Nessie, for the storage, and we will be able to support massive data sets and compute on them in situ. One comment I want to sort of say that, there's this analysis that happens. I think the question you had about the human resource is absolutely true. I think that we have an unbelievable opportunity from computational resources and storage resources. The economics are extremely compelling to actually use the MGH PCC. For those of you that don't know, it's sort of the largest data center available to academics anywhere in the world, is a place where we can sit our computing. What the Wayne's team does the economics, and from a computational cycle perspective, it's about a factor of, what would you say, cheaper than the public cloud on demand? Over 10, and then, we have the economics right for the computational resources. I don't think any public cloud could compete with us, and with the efforts we're doing with industry, the goal of the MOC is not just to be a place where you lose your data, Azer, but actually a place which we're prototyping the techniques that could be used to actually offer, from academic institutions, something that offers a lot of the same services. So I think we're in really unique and good position here to offer much better economic stuff. And this example of being able to host massive data sets and be able to access them from anywhere, like part of the problem that Harvard had was hosting them on AWS. You get, it's free to actually move your data into the cloud, but pulling your data out of the cloud is actually really expensive. And it's not because bits are more expensive traveling one way or the other. It's because they're trying to lock you into it. So I think we've got a unique set of assets. It's going to be a couple of years till I think it's really, really solid. But we're in a position to address this that nobody else is.
Yeah, I wanted to second.
I don't think you're on the mic.
Hello?
Yeah. Yeah, I wanted to just follow on to Oran's comment because this drives me crazy. You have to realize that that this is a national problem, but we're in a unique position to make a big dent in it. So there are 8 research universities within walking distance, and this facility that Oran's talking about is 5 of the biggest ones got together and made this facility that's in Holyoke, Massachusetts. It's 100 miles away from here, and this is a way of solving the scaling up problems. So Wayne has 15,000 cores, but according to John, who's the executive director, MGH PCC as a whole has 350,000 cores on the floor. There's room to double the facility. Aura is making software so that we can put our facilities into a shareable pool. And this project that Oran mentioned before is this NSF-funded project called Nessie, which is regional storage. So we're going to pool our storage resources. And once we do that, we'll have unique advantages compared to other universities. And solving a problem like what you were talking about is going to be totally trivial.
So we have 5 minutes left. I want to make sure that, okay, Margaret, you have a question, and then I have a comment to make.
Yeah, thank you for saying that. I think we actually have a great opportunity at BU, and one of the opportunities is actually that you all got together here on this one panel, and that's so different from other universities that we all pull together, and we have a visionary president who has this data science initiative that is actually going to figure out a structure now so that these panels can happen. I don't know, how often do you see each other? Is this a unique thing, once a year kind of thing, right? A once a year thing for Buds Day. But in the future, we're going to have a structure for data science here at BU where this can happen more often, and where the pipeline of students actually who are being taught in data science and can help out will also be created. So BU doesn't want to be worrying like in 10 years that there's nobody that can actually do these things because we forgot to teach them, right? So we're starting these new programs, and that's all going to be part of this new structure and new initiative. So thank you so much. I think just seeing you there, it's so exciting what we have at BU.
Thank you, Margaret. Wow, with that positive note, maybe I don't want to say anything else. That's wonderful. I just want to say that we focused a lot on research, obviously, because that's probably what faculty do and so on. But don't forget about teaching. This goes back to the human pipeline, I mean, it starts with undergraduates. And I know that for SAIL, for example, recruiting our own undergraduates to work in SAIL and then sort of maybe transition to industry and so on. We have a pipeline. This is actually a way to show the world how we can do it right. So I think we have an opportunity. What Jean said about the committee of visitors who came to visit us twice, actually back in the spring and then most recently just a week ago. There's a recognition that things are different. In their own institutions, they cannot get their equivalent of ISNT and faculty to talk to one another or whatever. So I think we have an interesting ecosystem, the connection between education and research. I want to emphasize that because at the end of the day, we are a university. At the end of the day, you know, every faculty will do the research because that's our bread and butter, we have to do it. But the university has to deliver also a good education. And that's where a lot of resources can go if we can figure out a way to differentiate ourselves. So thank you all. I really want to thank the panelists for being here, and let's have a break and come back in 15 minutes.